Saxon's Trig, Lesson 91, Geometric Progressions. So we've already talked about arithmetic progressions in which we had a pattern that was a sub 1 plus whatever the number is that you're doing minus 1, and then multiply that by the common difference. And then if you're talking about getting that would be the a sub n, I guess, if I finish that concept. That was the actual arithmetic formula because it was addition with arithmetic. Geometric implies a multiplication. So if my pattern is to multiply by 2 each time, let's just do an example. So 8 times 2 is 16, 16 times 2 is 32, times 2 again is 64, and so on. All right, common difference. Geometric, okay, yeah, all right. Just want to make sure I hadn't skipped anything. So the new pattern here, obviously the 8 is a sub 1, and we know that we're multiplying by something. So if I call this one a sub 2, it would be a sub 1 multiplying with whatever the common ratio is, because I did 8 times 2 to get to 16. So 8 times something. Now, how many times do I need to use that something in the multiply? So like if that were r here and r here, that would be an r squared. Oh, okay. Well, in the pattern here in arithmetic, I did n minus 1. It's the same thing happening here. The exponent is the n minus 1. So how many times would I want to use the common ratio of 2 to get over here to 32? 1, 2, yep. So for the third pattern, it's going to be r squared. All right, let me write it over here. So for the geometric, it is a sub 1 r to the n minus 1 gives you your a sub n number in the geometric, and here is the arithmetic formulas. Okay, example 1. Find the fifth term in the geometric sequence whose first term is negative 2, multiplying with the common ratio. And it wants the fifth term, so we're solving for a sub 5. So my r is going to have 5 minus 1. 4 is going to be its exponent, and whose common ratio is negative 3. I can now fill it in. So negative 3 4 times. Negative 3 times negative 3 is positive 9. 9 times negative 3 is negative 27. Times another negative 3 should be positive 81. Times negative 2. And a sub 5 should be negative 162. Example 2. Find 3 geometric means between 4 and 64. So just like the arithmetic, the mean means you've got that many blanks filled in between the provided numbers. And this one is, of course, a sub 1. This one is the 1, 2, 3, 4, 5th pattern. So we know that 64 equals a sub 1, which is 4, multiplying with the common ratio, which we don't know. And since this was the 5th, 5 minus 1 makes the exponent 4. So we try to solve for a common ratio here. 64 divided by 4 is 16 equals r to the 4th. What number 4 times gives me 16? That's 2. So now the common ratio is 2. I'm multiplying by 2 every time. However, before I do that, because this was even, my answers can be positive or negative 2. Now, if it's an odd exponent, you're limited to whatever the answer is. But if this is even, you get both a positive and a negative answer. So I will actually have 2 sets. So when I multiply by the 2, I get 8, 16, 32, and then I verify the 64. If I go with the negative 2, 4 times negative 2 is negative 8, times negative 2 is again positive 16, negative 32, positive 64. So here are 2 sets of answers for a geometric mean between 4 and 64. Example 3, find 2 geometric means between 2 and 1/4. Again, we're going to do our pattern. So 1/4 equals starting times the ratio, which I don't know. This is the 1, 2, 3, 4th number, and that means 4 minus 1 makes the exponent 3. So we're going to divide by 2. So over here, if you're dividing by a 2, you're multiplying by its flipped, so that's the 1/2. So if you don't do it on the calculator, you're doing it manually, you're getting 1/8. What number 3 times will give you 1/8? Well, the cubed root of 1 is 1, the cubed root of 8 is 2, so there's your common ratio of 1/2. Now, I said on an odd exponent, I only have whatever it comes out to be. So this was positive 1/2, so that's what we're going to do. 2 times 1/2 is 1, 1 times 1/2 is 1/2, and just to verify, 1/2 times 1/2 is 1/4, so there's the 2 geometric means. And finally, example 4. Find 3 geometric means between -16 and -1. So we're going to do our pattern. -1 equals the original -16 times the common ratio, which we don't know, and this is the 1, 2, 3, 4, 5th one. 5 minus 1 makes the exponent 4. -1 divided by -16 is positive 1/16 is r to the 4th. That means my r is going to be both a positive and a negative. The 4th root of 1 is 1. What number 4 times gives me 16? 2. So again, I'll have 2 sets of answers. -16 times the positive 1/2 is going to be -8. -8 times the positive 1/2 is -4. -4 times positive 1/2 is -2. Double checking, -2 times 1/2 is -1, all right? Now let's do the negatives. -16 times -1/2 is a positive 8. 8 times -1/2 is -4 still. -4 times -1/2 is positive 2, and 2 times -1/2 is -1. So here's the 2 sets of answers.